Welcome to
FamilyMath151.
FamilyMath151. So today we're going to talk about area, perimeter, and fence posts. Okay?
Yeah.
That sounds fun. So the first thing we're going to do is we're going to pretend our little snap cubes are 1 by 1 squares. Yeah, the fact that they're cubes isn't so important today. So our snap cubes are going to be 1 by 1, which means they have a perimeter of
4.
4. So the perimeter is 4. And what's the area?
1.
1. And how did you figure that out?
It's length. Area's length times width.
For what? For what sort of
For
object?
rectangles and squares.
For rectangles and squares. And which statement is right? Squares are rectangles or rectangles are squares?
The first one.
What was that statement?
Squares are rectangles.
All right,
They're
so
equilateral rectangles.
squares are rectangles. Okay. And how did you figure out the perimeter was 4?
Well, you add all of the sides.
Okay. And does it have to be a square for that to be true?
No, you can do it for anything.
Anything, just add up how it is all the way around. And then what I mean about fence posts is we're going to put posts on the outside corners of all of our objects that we make. So in this one, how many fence posts do we need to put it on all the outside corners? Or not all the outside bits, every length one, I mean.
4.
Looks like 4. Okay. So I want you to make a simple shape out of 4 snap cubes where the snap cubes are all lined up perfectly together. So you can make any shape you want out of 4 snap cubes. Go ahead. Either.
Well, you can make this shape.
Like T.
Ah, okay.
Sort of a T.
Beautiful. I love that shape. Okay, now, so let's see if we can talk about the perimeter and area and the number of fence posts we need. I have to be a little bit more precise about what I mean by the fence posts. So go ahead. Tell me, one of you tell me the perimeter of this?
Well,
all of these are 1 by 1 sides, and you don't count these sides.
don't count the sides that intersect with other sides.
Okay, awesome.
So it's the perimeter of 4 squares, which would be 16, minus the 3 side minus. You have to subtract 6 because this is really 2 sides.
Ah, okay. That's actually a very interesting way of looking at it. Let me see if I can move some of these out of the way. Oops, sorry, didn't mean to. All right, so you're saying what I could do is I could take my perimeter times 4, so 4 times 4 for an individual cube, and then subtract away all the intersecting sides because they're not part of the outside that goes around.
Yeah.
So each intersecting side has 2, so I subtract 1, 2, 3. 3 times 2, and I get 16 minus 6, which is
10.
10. Is there any other way to see that the perimeter is 10? Yeah, go ahead. Let your brother do it.
You could start at the top and just count all the sides.
Okay, go ahead.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Actually, it's...
Well, why don't we do this? Why don't we draw this shape out? Looks like it goes like this. Okay, maybe it's easier to mark the sides now. Why don't you put a check mark on them or a little mark when you count a side?
Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10.
Super. High five. Okay, now we'll move on to the fence post in just a second. But can you tell me the area of this shape?
Well, it's 4 squares, and none of the squares overlap each other.
Okay.
So the area is going to be 4.
Ah. Okay. Can you explain why the area is 4?
Well, we said earlier that the area of this small square is 1.
Mm-hmm.
And there's 4 of them. So that means the area is 4. But you could also calculate the area.
Ooh.
But
How would you calculate it?
well, you'd have to do length times width, which I don't think that would be super easy.
Yeah, probably not. Probably not. But it's here we just noticed we have 4 squares sort of put together, so the area is 4. The perimeter there were two different ways to do it. You had a really clever way, adding up all the edges and then subtracting the overlaps.
Yeah.
And then you had a nice way too, which is just like pretend you're an ant and walk around.
There.
All right, ready to talk about fence posts?
Yeah.
Yeah.